Okay. All right, guys. So today we're starting chapter 3. I know that there's a good number of you who have not finished the chapter 2 test. So leadership sometime, find time to come in and get that done throughout this week. Or if you want to, if you're able to stay after 8th hour and have transportation that's not the bus, just let me know. I can stay after most days. Okay. And I went back and forth on giving y'all another day, but we do need to move on because most of those tests I do set up so that they are fit in the 45-minute time slot. Because if you're having to try to relearn it or think through it, it would take more time. And that's also why there wasn't a number 8 on the test. If y'all notice that problem number 8 was gone, there was weird blanks on any of the tests where it just almost looked like something was pulled out. I did that on purpose because I'll take the test myself, and if it takes me too long, I think it's more than 9 minutes, I'll start pulling things out to make sure that y'all can finish it in 45. Huh? More than 9 minutes? Mm-hmm. Well, I've also been doing it and I know a lot of the shortcuts and other things, so I use a factor scale of 5. Because whatever I do, I multiply by 5, or how long it takes me. And y'all should be able to do in the same amount.
That was a slight flex on that. I'm not even gonna lie.
Yeah. But I also get. And I'll also kind of fix it. That's just the best way I can judge it for y'all's time. Now, what we're going to do today, tomorrow, and Friday is factoring. Now, we'll work through this here first. So 4x, it's following the main steps. So it's going to, hopefully, y'all will find this easy. Now, multiplying these two together, y'all did this in Algebra 1, is distributive. We're going to use the distributive property. So we'll do 4x times x, which is 4 squared. Because x times x would be x squared, and then 4 times 1 would be 4. And then we would do 4x times the negative 3. 4 times negative 3 would be, and we would still have the x. Then we'd have 5 times negative x, which would be negative 5x. And negative 5 times negative 3 would be plus 15. The negative and negative make 8. Now we do need to combine our like terms. 4x squared. Well, negative 12x minus 5x is negative 17x plus 15. And that's just using the distributive property. And we get to a quadratic, our ax squared plus bx plus c. But what we're going to be doing with factoring is starting out with this here and returning it back into factored form. We're going back to the 2 sets of parentheses. And that's what we're going to be doing with factoring. Now, I feel confident that y'all can multiply these 2 sets of parentheses using distributive property or FOIL, first, outer, inner, last, quite well, so we're not going to be looking too closely at those. Now, we're just going to move on to the page here. Now, previously you factored polynomials in the form ax squared plus bx plus c, where a is equal to 1. So we're talking about something, you don't have to write this down, but something like this here, x squared plus 4x plus 4. Y'all did that in Algebra 1, broke it down, it ended up being x plus 2 times x plus 2. Now what we're going to be looking at is polynomials that have an a number in front of x squared that's not 1. Now, out of all the different ways that there are, the way that I'm going to show you is the way that I see that this works best. It's very systematic in how we do it. But I feel like it's what I think is kind of the easiest way to do it with the least amount of steps. Now, there are other methods that do work, and if you like those methods, you can use those. But in the 5 steps that we're going to use, the first step is going to be to find the greatest common factor. Is there a common number or variable in all the terms? If there is, we're going to factor it out. our second step is going to be to write two sets of parentheses with 3 spaces. So first we're going to pull out the greatest common factor, and then we're going to write 2 sets of parentheses with 3 spaces. Step number 3 is going to be to find the sign. If the third term is positive, then the signs will be the same and match the sign of the middle term. Yeah, I also have these written on the whiteboard. So if y'all want to copy them down there, that's fine. B, if the third term, I, is negative, then the signs, scroll down, are opposite. If the third term is negative, then the signs are opposite. Our fourth step is to find the factors of the first and third term. And then last but not least is to plug and check. And these here are the key steps that I do in trying to factor. And as long as we have kind of a quadratic or a 3-term, there are some quartic, let's see here, quadratic, cubic, quartic, degree 4 polynomials that will work. They just have to be in a certain setup. But we'll be mainly looking at quadratics with this here. Now we could have it with x and y. So x squared plus xy, or 2xy plus y squared would work with this well. That's why we're referring to it as the third term, not the constant term, because constant term is a number without a variable. And most of the ones we'll look at, it will be a constant term, but third term works as well. Now, as confusing as those kind of steps seem, they're actually going to flow quite seamlessly. So when we look at this here, this first one, we want to factor 5x squared plus 15x plus 10. Is there a greatest common factor? Well, 5. 5 will divide into all 3, yes? So we'll put a 5 in a parentheses. And essentially what we're doing is dividing each of these terms by 5. Well, 5x squared divided by 5 would be just x squared. 15x divided by 5 would be plus 3x. And 10 divided by 5 would be plus 2. And what's nice about this here is that now we're dealing with smaller terms. Because instead of 5x squared, we just have x squared. Instead of 10, we have 2. And that's it. We don't have any other common factors, do we? Okay, so that finishes step 1. Step 2. Write 2 sets of parentheses with 3 spaces. Because when we started off and multiplied those two together, well, I had a number with x, I had a sign, and then I had a number, yes? Well, that's how many things? 3, isn't it? And in both of those sets of parentheses, I had 3 things. I had 2 numbers, or 1 with a variable and a sign. So doing this here really helps us space out these parentheses so that when we fill things in, it's not going to be all crammed together. Now, as we get used to, and as you all get used to this, I mean, you can drop the 3 spaces. I don't put the 3 spaces because I have a good idea of how big the parentheses need to be. If they're too big, that's fine. If they're too small, it gets a little tight. But we have this set up here, which takes us through step 2, yes? Step number 3, and this is actually quite interesting that it works as well as it does, is we want to find the sign. Now it says if the third term is positive, the signs are the same and they match the sign of the middle term. Okay, I'm going to show you guys kind of why this is as nice as it is. Well, here both of the signs are negative, yes? And it's really attached to the 5 and 3. Well, what is, we already figured it out, negative 5 times negative 3. The negative times a negative is a positive. What's the other setup where we would end up with the multiplication being positive? As if they are both what? Positive, because a positive times a positive is a positive. A negative times a negative is a positive. So the only way I can multiply 2 numbers together and it ends up being positive is if they are both positive or both negative. Okay, well that makes sense. We're looking back at this here in step 3. Because I'm just showing you guys the kind of uniqueness of how this works. Now the middle term we got from doing 4x times negative 3 and x times negative 5, where these two here are the 2 middle terms that end up becoming the 1, yes? Yes. Now when we multiplied it, they both were negative, and when we add 2 negatives, it stays negative. If we add 2 positives, they stay positive, yes? So wait a minute. So when I multiply together 2 of the same sign, I get positive, yes? But when I combine it, the sign stays true, yes? And that's where the ingeniousness of this comes in, because if the third term's positive, well, we know it has to be the same, yes? And the same signs are always going to match the sign of the middle term. So that means for this here, where we don't have it in those 2 sets of parentheses kind of telling us what it is already, well, the positive 2 tells me that the signs have to be either both positive or both negative, is what that tells me. And the middle one tells me that they're actually both positive and that's really, so if the third term's positive, the signs are the same and they match the sign of the middle term. That's where why that works. And that's kind of nice, because what that does is when we start looking for the factors of 2, we don't have to look at positive and negative cases. All the signs are taken care of. Now, the other part of it was if the constant term is negative, the signs are opposite. Because if for me to get a negative number with multiplication, one has to be positive, the other has to be, that's the only setup we have. Okay, so that takes care of steps 1, 2, and that brings us to step 4. Find the factors of the first and third term. Well, the first term is x squared. What are the factors of x squared? 1 times x squared, yes? Or x times x. Now, we're going to stick with x and x because 1 and x squared actually doesn't give us anything, because I know the other number is just going to be a constant term. Well, those two would add together, and that's about it. So really with x and x squared is telling me that I could have factored x out of the top, and it doesn't quite work. So really the only factors for x squared are going to be x and x. Now the case that we would have an x squared in one of them would be like x cubed. I could have x squared and x, because we need an x in both. Now if there's only one set of factors, plug them in. There's what is step 5, plug and check. So we're just plugging them in. The factors of 2 are, what two things multiply together to give me 2? 2 and 1 or 1 and 2. There's only one set. We plug them in. Now, a lot of stuff in geometry and Algebra 1, there's been a set way that you do it, the set way we plug in. Like with last chapter, we found the specific values of h and k, and we plugged them in where their respective spots are, or where p was. Here, okay, x squared is the first one, so we plug it in the first spot. 2 is in the last, so we plug it in the last spot in each one of these. I just threw them in there, yes? And that's fine, because step number 5 is plug and check. Whenever we're doing these, even when solving these, it's always good to check to make sure we got the correct thing. And the way we're going to check it is just multiplying it back out. So if we do the distributive property, well, we would do what first? X times x, right? Wait a minute, where did I get x and x from? They're the factors of x squared, yes? So should they multiply together to get me back to x squared? Well, yes, that's where we got it from, yes? Now, some books will actually say we need to multiply it all the way through. Wait a minute. No, not that. That's what I want to do. But here and here, well, we got those two from squared and 2. So since they're factors of the first and third term, shouldn't those always get me back to the first and third term? Well, yeah. I don't ever do that step because I know that I got those from the first and third term. They're the factors of them. They should multiply back together to be the first and third term. So I don't focus on that one. But what I do focus on, and we'll, this nice peach color, is this one here and this one here. Because depending on how we plug the numbers in, the middle term will change. The first and third term should still multiply together because those are factors. Now, x times 2 would be 2x. 1 times x would be plus x. And 2x plus x is 3x. Well, what is our middle term? Positive 3x. Those match up, yes? So what that tells me is that this is the correct factorization. Because we could have gone on and done the whole multiplication and end up getting x times x is our x squared. 1 times 2 is our plus 2. We would have the whole thing. But the main one that ends up changing is the x times 2 and the 1 times x. Because that's the only one that will be changing depending on the setup. Because no matter how we set it up, the first terms, our x times x, whatever's in those two spots, should get us back to our x squared, our first term. The 1 and 2, when we multiply the numbers in those two spots, they should get back to our third term. That's how we got them to begin with. The only thing that's changing is the number in the middle. Questions on this here? Let's look at this one. 4x squared plus 32x plus 60. Is there a greatest common factor? 4. So we can factor the 4 out, which is really just dividing each one of these by 4. Well, 4 divided by 4x squared would be just x squared. 4 divided by 32x would be plus. And 60 divided by 4 is 15. And you can do these in the calculator, just don't put the x. Because we can do 32 divided by 4 or 60 divided by 4. Just, we'll write the x in. Because again, for the TI-84 Plus and the TI-30 xs, it needs a value for x, and it's just going to put whatever was the last inputted, which would probably be 0. So it'll tell you that 32x divided by 4 is 0, which isn't right, because so just don't be putting variables in. Okay, that was step 1. Step 2 is? Two sets of parentheses with 3 spaces, kind of giving our setup for what we're going to plug in. Yes. And that's it. So I'm going to look at step 3, which is the signs. Since our third term is positive, the signs are the same, and they match the sign of the middle term, which is also positive. So the two signs that are going to go in here are going to be plus and plus. Which brings us to step number 4, the factors of the first and third term. So the factors of x squared, x and x, because that's the only setup that we have. X times x is the only way we can factor x squared. So the 4 was from being factored out. Now the 15, factors of 15 are 1 times 15 or 3 times 5. As we just said, well, 3 and 5 are ones that we can try first. And last but not least, we can check it. X times 5 is 5x. 3 times x is plus 3x. And 5x plus 3x is 8x. So that tells me that since it does match up with our middle term here. Yep. Because we could do the whole multiplication, but the x and x, well, where did I get them? Well, they're the factors of x squared. So if I were to check it, well, obviously they are going to multiply back together to give me x squared. Yeah. And the 3 and 5, we don't have to check yet, because how did we get 3 and 5? Well, they're factors of 15, so they should multiply back together to give me 15. And that's it.
Are you, even though like I passed the test, am I allowed to come in and like
Yes. Any other questions on this here? So we'll look at the next one, and the only time you really can't do makeup points is if, yeah. And you can't do makeup points on the bonus, because they're points added on, you don't actually lose any. Yep, and you get a point for trying. So let's look at this one here. Step number 1, is there a greatest common factor? No. So we move on to step number 2. There are a lot of other ways to do it. There's the cross method to doing it, and that works. There is the square method, because we're actually looking at two things being squared, setting it up that way. I think it is, because it does work out and we don't have to split anything up. The X method does work pretty well, but we have to deal with factors of positive and negative cases and look at every possible choice and plug in. I just like how this kind of flows very well. So the next thing would be finding the sign. If the third term is positive, the signs are the same and they match the sign of the middle term. If the third term is negative, the signs are opposite. Well, here the third term is. So the signs are the same and they match the sign of the middle term, which is. So they would both be.
So you look at the last number and then the middle sign?
Yes. Because the way we get the last number from using the distributive property is, the way that we get 3 is from this number and this number being multiplied together. So the only way we can have it be positive is either if they're both positive or both negative. Now, when we combine the middle term and we're adding it, So the middle term tells me if they're both going to be positive or both going to be negative. Now we can look at the factors of the first and third term. So the factors of 3 would be 1 and 3. And since there's only one set of factors, we can just throw them in. Doesn't matter where they land. For 1 and 3? Yep. Yeah. Because since 3 is prime, the only factors are 1 in itself. Now, I skipped over the 4x squared. Now, the x squared is going to be x and x. There's only one setup for it, so we'll just throw it in. Now, the factors of 4 are 1 and 4, or which one do we want to try first? 2 and 2. So I'll plug them in here. And as we've been saying, well, 2x times 2x is still 4x squared, because that's how we got it. 1 times 3 is still going to be 3. So the main one that we're looking at is 3, and 1 times 2x. Well, 2x times 3 is 6x. 1 times 2x is plus 2x, and 6x plus 2x is 8x. That's what we wanted. Is it? No, what did we want? 13x. Okay. So what that tells me is that this setup, 2x plus 1 times 2x plus 3, is not the correct factorization. So we could switch the 2x and 2x, yes? Well, it would just give me back where we are, yes? So how about switching the 1 and 3? Well, it's still going to be the same thing, yes? Because 2x and plus, it gave us the exact same thing. 1 times 4. So we can erase the 2x, or the 2 and 2, and rewrite 1 and 4, or 4 and 1. Okay. And again, that's why we plug and check.
Okay, see, how'd you get the 1 and 4 and the 2 and 2 like that? Because 1 and 4 is
So factors of 4. We're looking for two numbers that multiply together to give me 4. Well, 1 and 4, and 2 times.
Oh, I thought they're like decimals.
Yep. Yeah, it's just the multiplication sign between them. Now, when we plug them in, it's really, you're going to pick which one you think will work. We'll plug them in, check if it does. If it does, we're done. If it doesn't, we try a new setup. Here, x times 3 would be 1 times 4x would be plus 7x. Now, we can switch the 1 and 4 because that will change it because of the 3. Because if I put the 4 first, we have 4 times 3, which is 1 times x is plus x, and 12x plus x is, so that's the correct setup. Now, the more of these that you do, and we have more that we're going to do here, we'll start seeing patterns of how the numbers work and start seeing what is going to be the more optimal setup that we can try. So a lot of this is just doing more of them and seeing how they work and how the numbers work. There isn't always a set rule of, okay, in this case, we're going to plug these numbers in here. It's just plugging and checking to seeing if we get it. Questions on this here? 3x squared minus 7x plus 2. Is there a greatest common factor between these three terms? Okay. Second step, 2 sets of parentheses with 3 spaces. Got it. Find the sign. As we look at the sign of the third term, and it is positive, so the signs are the same, and they match the sign of the middle term, which is negative. So that means both of these signs will be negative. Which brings us to step 4 to find the factors of the first and third term. Because for 2, we do have 1 and 2. 1 and 3. And we do just have x and x. Because 3x squared, the 3 is prime, so the only factors, two things that multiply together to give me 3 are 1 and 3. The only thing that's multiplied together to give me x squared is x and x, so that sets 3x and x. Now 2, again, is prime. The only things that multiply together to be 2 are 1 and 2, yes? We good with this so far? Yes. Now we just need to check. Well, 3x times negative 2 is negative 6x. Negative 1 times x would be
Positive. Because negative times a negative, right? No, 3x is. Oh, my bad.
3x is positive. But yes, if it was negative, then it would be positive. And negative 1 times x would be negative x, which gives us negative 7x. Is that what we wanted? Since the middle term is negative 7x. And that's it. Questions on this here? Let's look at this one. Two x squared plus 7x plus 6 is their greatest common factor. No, the 7, because 2 and 6 do, but the 7 kind of throws everything off. So, okay, so we'll move on to step 2. Two sets of parentheses with 3 spaces. That satisfies step number 2. Step number 3 is to find the signs. If the constant term or the third term is positive, the signs are the same and they match the sign of the middle term. If the third term is negative, the signs are opposite. Well, the sign of the third term is positive, so the signs are the same and they are both positive. So plus and plus. Now we want to find the factors of the first and third term. So 2x squared, well, x squared's only factors are x and, what are the factors of 2? 1 and 2, so it's really, I'll just put 2 here. Because again, when we're plugging this stuff in, it really doesn't matter where we put it for now, because when we check it, it'll tell us, yes, we have it right, or no, we need to fix it. Now the factors of 6 are 1 and 6, or which one do we want to try first? Yep. 1 and 6, or let's go 6 and 1. And we can check it. Well, 2x times 1 is 2x. 6 times x is plus, and that gives us 8x, yes? Now, I set it up this, we can, but I want to look at this here real quick, because I set it up this way on purpose. 2x plus 6, is there a greatest common factor here?
Yes.
Well, if there's a greatest common factor, it means I could factor it out and leave us with x plus 3 times x plus 1. Wait a minute. Was there a greatest common factor to begin with? So could we have a greatest common factor in either of the parentheses? No, if there's not one to begin with, we can't have one in the parentheses. Now, okay, we can kind of see that. But another reason that it's nice to know that is what other number can't be next to the 2x? 2, because what are the other factors of 6? 2 and 3. So if I try those, I know the 2 cannot be in the same parentheses as the 2x. So that means one of the setups where we're plugging things in, we don't have to do that. Now, if that's a little confusing, we don't have to worry about it. Because again, we just plugged it in and it told us immediately it didn't work, right? So even if I don't remember that, the check will still tell us if it's right or wrong. It'll still do it. I will tell you that 1 and 6 won't work because 2x times 6 would be 12x plus x would give us 13x. Now this here, we can check it. 2x times 2 is 3 times x is plus, which gives us 7x. Hopefully, are y'all starting to get the pattern of how this is working? We're doing good, Caleb? Huh? You got questions?
Yeah, I'm working tomorrow.
Because again, what we're doing tomorrow and the next day are just different setups of these here. I want to skip one and look at these. All right, Caleb, I'm going to pick on you on this one. Other Caleb. So, let's look through the steps. Is there a greatest common factor between 2x squared, 5x, and 7? Is there a number or variable that I can divide or has in common in all three? No. Okay. Yeah. The second, so there's no greatest common factor. We don't have to do anything for step 1. Step 2 is write 2 sets of parentheses. Okay. Parentheses, 1, 2, 3. Close parentheses. Open parentheses, 1, 2, 3. Is that it for step number 2? Okay, step number 3, find the signs. So if the third term is positive, the signs are the same and they match the middle term. If the third term is negative, the signs are opposite. So, okay, so I'm just coming over here to the third term, the constant term. Is it positive or negative? Negative, okay. So the third term is negative, so these signs are opposite. So, well, yes, because one would be positive and the other would be negative. Because for them to be opposite, one's positive, one's negative. If it was positive, okay, I look at the middle term, and that's what it's going to be. So here they're opposite. So that takes us through steps 1 through 3. Step number 4, find the factors of the first and third term. So let's look purely at the first term here. It would be 1 and 2, because 1 times 2 is 2. And x squared is x times x, because x times x would give us x squared, so we would have x and x. Since it's the first term, in each of the first spots, we'll have x and x. Now 2 and 1, 2 times 1 would be 2. We can put 2 and 1. We don't necessarily have to write 1 since there's an x there. And that's it. Questions on this so far? And the third term is 7. Now, the question that I do get sometimes is, what about this negative in front of the 7? Well, we took care of that in step 3. We don't have to worry about the signs because we took care of it already. And that's one of the things I like about this method, is that in others, at this point, when we're looking at the factors, we would have to look at the signs. To say 1 times negative 7 or 7 times negative 1. We'd have to factor that in. But here, since it's already been taken care of, the only factors of 7 are 1 times 7. And then we can check it. And 2x times negative 7 would be negative 14x. 1 times x would be negative 14 plus 1, or 1 minus 14 would be negative. What did we want? Okay, so that's not the correct setup. So we can switch the 1 and 7 or the 2 and 1. What do we want to switch? So let's switch the 1 and 7 and see what happens. So 7 and 1. Now 2x times negative 1 would be negative 2x. 7 times x would be plus 7x. And negative 2x plus 7x is? Well, the 7's bigger, so it would be 5x. And that's what we want, yes? It's close, isn't it? So, since it is the correct number, yes, but the wrong sign, so it's an easy fix. Because we can change the signs. Because now it'd be 2x times 1, which would be a positive 2x, yes? Negative 7 times x would not be positive, would be negative, which now makes this negative. So whenever we're dealing with these here and we get the correct number but wrong sign, flip the signs. Because in some cases we could flip one of the numbers and get the same thing, like with our 2x and 2x on the first one, because we notice, okay, flipping the 2x's doesn't change anything. But here, we can just flip the signs and we get the right answer. Now, one of the big things with this, and I'm going to scroll over to this here, is if you've noticed so far, it's not that there's a correct method that if we know the correct process of how to do this, it works every time. Well, no, because we do have greatest common factor, 1, 2, 3. Steps 1, 2, and 3 is all setting up the problem. Steps 4 and 5 is just plugging stuff in. Did it work? Yes or no. If it didn't work, rearrange it, try it again. Did it work? Yes or no. If no, rearrange it, try again. And that's all there is to it. I'll get that in a second. But the more that we do this, the way that we should set it up, or the way that's most likely going to work best, we'll figure it out as we do it. You'll get to see the patterns and see which way's best as we work it more.